The .NET Core podcast is supported by our listeners who have become patrons. To see a full list of the patrons, or to join them, head over to .NETCore.show/patrons. Hello everyone and welcome to the .NET Core Podcast, an award-winning podcast where we reach into the core of the .NET technology stack and, with the help of the .NET community, present you with the information that you need in order to grok the many moving parts of one of the biggest cross-platform, multi-application frameworks on the planet. I am your host, Jamie GaProgMan Taylor. In this episode, I talked with Jason Oles about clean code, what clean code is, how to keep your .NET code bases clean, and his recent book, Clean Code in C#. So I guess you could say he's a bit of an expert. Along the way, Jason helped describe what clean code actually looks like and shared some of his top tips for keeping your code bases clean, and why that's important for long-lived code bases. One thing just before we begin, the audio for this interview ended up a little rough in places, but our editor, Mark, has done the very best that he could to clean it all up, and I think he's done an amazing job. So I ask that you stick with it, because Jason has some really good points to make. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. Thank you ever so much, Jason, for joining us today. I really, really appreciate when anyone can take some time out to talk to us because, everyone's really busy, regardless of what's going on in the world. Everyone is really busy, right? And so I really appreciate it. We're going to talk a little bit about your career and a little bit about a book that you've just released. But like I say, welcome to the show and thank you ever so much.
Thank you.
So would you mind maybe just letting the listeners know a little bit about you, if that's all right? A little bit maybe about a little bit of your background, or maybe things like that, just so that then the listeners know a little bit more about you as they're listening to the show. Is that okay?
Yeah, that's great. I've been programming since 1999. The main programming languages I have used are Visual Basic 6, Visual Basic.NET when it first came out, Visual C#, HTML, JavaScript, CSS and Angular, as well as some Java. My preferred programming language is most definitely C#, and my favourite programming environment is Visual Studio. I have used other environments, but I just really like Visual Studio with the way it's got like the debugging features, and with C# it's just so nice and so clean, and it's really powerful. I like the way you can organise your C# files. The syntax works well for me. Plus I like the tools and capabilities, especially when it comes to desktop applications. I just love developing like UInforms, WPF. Just really, really nice tool to use. I've developed a number of applications that include reporting applications, marketing software, mobile job tracking software for field engineers, document management systems for law firms, banking software for data migration between Oracle and SQL Server databases, and educational software, which I'm currently working on now, that tests for dyslexia through the use of tests that are like games, which is quite interesting to work on actually. On a personal level, I like walking, gardening and doing astronomy. I have also dabbled in making a bit of music, which you can hear on Bandcamp at mebsuta.bandcamp.com. I've also used to take part in chess competitions and did win a few. So yeah, it's a bit about me.
Awesome. I always do like to hear about a little bit about what people do outside of development, because I've noticed that there are a lot of people who work as developers, technologists, in technology, however you want to put it, who are also really creative outside of that. So, I mean, the listeners can't see it, but earlier on, before we started recording, I moved my camera around, and I don't know whether you noticed, but I do have a bass guitar sitting right next to me in a flight case. And that's because, I dabble with bass a little bit, and I found that there's almost like I would say around a 50-50 split, I think, of developers who are also interested in music, and I wonder if that's because music it's one of those wonderfully creative things that you can, just like with programming, you start with nothing and end up with something, right?
Yeah.
But it also follows a really strict set of rules as well. And I think programming kind of helps with that too. There's only you have so many data types. And, as we'll maybe discuss later on, you have rules about how to make your code clean and reusable. And I'm sure that there are probably rules about how to make your music, for want of a better phrase, clean, but not in a music sense, but like clean, easy to listen or things like that. I'm sure that there are similar rules in place.
Yeah, there is. A lot of it as well is actually driven by mathematics, from what I've read up on.
Yeah, I remember, so before, like, straight out of uni, I spent a little time and did some teacher training, and I was in the maths department, and one of my tasks was to build connections between maths/math, depending on, because there's a lot of American listeners, between the math department and different departments throughout the school. And one of the things that I made like a big poster about was, music is kind of just maths, but for your ears. A musician uses maths to create wiggly air, and the wiggly air is then picked up by your ears and converted back into the sounds that that the musicians originally envisioned. And somehow that affects your emotions and stuff like that. So there was this one big, I want to say A2 poster that I described how maths and physics and music are all sort of intimately related. But okay, so we are here to talk a little bit about a book that you've released recently, and I was wondering, do you have maybe an elevator pitch for the book? I know that it is called Clean Code in C#. And for the background of the listeners, I have read the book. Full disclosure, I have read it, but obviously I'm going to be asking some questions as if I haven't read it, right?
Yeah.
So would you mind, if you have an elevator pitch for it, giving us an elevator pitch for Clean Code in C#?
Yeah. From my experience in working with various pieces of software in different companies, you see a wide variety of code. Some of it's like really easy to manage, really easy to expand, and people are working on it. Then you get other code, and it's really intermingled, really hard to untangle. You can't expand it, and it's just so hard to work on. And so when you're company and your livelihood is actually the code base, but one thing you don't really want is a high turnaround, because your code base is really horrible and people just don't want to work on it. And the last thing you need as well is to be having a flagship product where it's absolutely your bread and butter, but it starts creaking and getting to a point with capacity, for example, where it just cannot take the strain, where you can't really do anything with it other than completely rewrite it from scratch. So you've got two potential ways forward. One is to actually refactor your code so that it's really nice and clean and tidy, where you take out all the dead code and where it's like properly laid out, so that anybody who comes in can read the code, easily find where things are, and start working on it and maintaining it. Or you can go down the road of starting from scratch, writing code, using like clean, like solid principles, for example. But also, as a developer, there's been like situations where programming teams have developed software thinking it's what the customer wants, and then when it comes to delivering the software, it's like, well, we didn't ask for this. But that's what the specification says, you see, because with the human language, you can have the same thing, but different people can interpret it differently. And so that's where the beauty of like TDD and BDD comes in. Because with test-driven development, obviously you know what the code needs to do, so you write your test, and it fails at first, and then you write the code just the bare minimum to make that code work, and then once it's working, you refactor as you need to. And with behavioural driven development, obviously you're given a specification, and you are only writing your code to that specification. So when you actually have finished writing your code, whatever you deliver to the customer, that is exactly what the customer wants. And so with this book, there's like tips and tricks for like writing clean code, just in general terms. But it also has an aspect of writing code using like TDD and BDD, so that as a programmer, you're going to have a confidence, one, that your code works when you actually release it to the quality assurance department, but also you know that whatever the business has asked for is exactly what you've developed. And so in that sense, your code is clean because it only contains the work the business requires of you. It doesn't require anything else. But also, if you like come to work on code and it's thinking like, well, I need to refactor this because obviously the code is creaking and we've been asked to make it work better, then there's lots of tools and tips and techniques to help you to actually do that. There's also like addressing cross-cutting concerns, for instance, like security, that sort of thing, where you can't really put it in a particular layer, but it's some of that's got to be addressed across layers. And there's tools in there that will help you actually use aspect-oriented programming so that you can actually take care of those concerns without cluttering your code as well. There's also like information on identifying poor quality code that needs to be refactored, and how you can actually secure your API keys to protect your data using things like Azure Key Vault. And also it talks you through as well various tools that are really good at helping you to refactor your code. So yeah, there's quite a lot in there, and the book itself it's not so much a theory book, but it's more geared towards giving you like the practical experience, so that once you've gone through it, you'll have the confidence to actually look at your own code and maybe think about ways in which your own code could be tidied up. But also when it comes to like working with legacy code within a business, or if you're looking for ideas like on sites like GitHub, where you're looking at third-party source, you can take that source and look at it and then just see if there's ways you can actually improve upon it and actually do better. Because a lot of code when you're working, like a lot of the places where I've worked, we've been that much under pressure, having to meet targets and deadlines. Sometimes you just have to sacrifice clean code and then come back to it and refactor when you've actually got the space to do so. That's usually when you have like a technical debt release, that kind of thing. But this book will certainly help you, one, to understand code smells and the kind of things to look out for, how to actually refactor them to make such smells clean, and also how from the start to implement solid principles so that the code that you do actually write is actually clean from the actual start. But also how to use tools that can actually identify problems that you wouldn't even dream of are actual issues, so that you can actually improve your code. So that when you've actually got your finished code base, it is actually really nice code base. It's clean, it's easy to understand, it's easy to maintain, and it's also a pleasure to work with.
Excellent. That like I say, I've read the book, and I've got to say that's a really sort of succinct way of describing it, if I'm honest. So yeah, brilliant. So if I'm thinking, I'd better pick this book up, do I need to know any of what clean code is and solid principles, and things like that? Do I need to know that these tools exist already and these practices exist already, or is it more a case of, okay, so let's talk about what solid means? A lot of people throw that word around. And, I was in a conversation with someone a few days ago, and they're like, yeah, I'm just using solid principles. I'm like, okay, let me stop you there. What's S mean? And they're like, and that's not a bad thing. It just, I feel like it's just a term that gets thrown around. But, does someone who's reading this book need to know about those beforehand, or are you taking them through what these things are?
No, the thing I don't like about a lot of books is they require you to have a lot of knowledge beforehand on a particular subject before you actually attack it in the actual book itself. So the approach I've taken with this book is to introduce people to topics so they don't actually need the knowledge up front, and provide enough to equip their appetite, and give them some practical experience as well. And then if what we'd like in the book, they can actually just take it further. So, but ideally, this is written for people where they've maybe new to programming, or they've been programming for many years. But it's a good introduction to such topics as solid, and a few other methodologies as well. And then what it does is it sows a seeds in their minds, and then they can actually go away, look at them in greater depth, because there's whole books written on the topic of solid, that people can actually buy to really go to the nth degree of making sure that they know exactly how it works, what it does, and now they can actually apply it in the real world. So there's a lot of topics where it's introductory, gives you the knowledge of what it is, why you would want to use it. And then other topics, they actually have practical experience associated with them, because as you're working through a lot of the steps what I actually take you through in using a particular technology and even applying it, such as the refactoring tool, Resharper, what you will end up with is you'll have no prior knowledge. You'll end up having the knowledge by the time you've actually used the tool, but you'll have the confidence to go with it, so that when it comes to being in a workplace, you will actually be able to actually apply the knowledge what you learn through the book. So the thing is, you don't really need any prior experience in reading this book, other than just a basic knowledge of C# and the wanting to actually write code that's nice and clean that you as an individual like to work on.
Okay. That makes sense, right? Because I have read technical books in the past where a lot of people talk about the Gang of Four book, right? I feel as though Gang of Four, which is the refactoring through design patterns or whatever the full title is, I'll make sure the full title's in the show notes, but I can never remember the full title. But the full title for Gang of Four really, really requires you to very quite deeply understand C++ and Smalltalk, I feel. And as someone who's done a little bit of C++ in the past, I was like, oh yeah, I totally get this. And then the next pattern, I'm like, I have no idea what's going on here.
Yeah.
So I'm glad to hear that I don't really need to have much more than, for want of a better phrase, a sort of basic or rudimentary experience with .NET and Visual Studio to actually get some use out of this. That's refreshing, I think.
Yeah.
Okay. So what about a lot of technical books sometimes just have reams and reams and reams of code attached, and some of them say, "Hey, go to this repo or whatever." Do I need to have a GitHub repo of my own code ready to refactor, or is there some like pre-provided code that's like, "Hey, here's some bad code, and we're going to fix it," or something?
No, basically, what I have a tendency to do in my writing is I'll provide you with examples to actually go through. Sometimes that is actually writing the code from scratch. So you'll, if you've got code that you've got your own repository, and I'm talking you through things, you can always apply it to your own repository. But the book does come with its own GitHub repository, and I don't require you to have any code. You just read through the book, work through it, and I try and provide as much of the code as possible without you having to like keep going and looking elsewhere. As long as you're in front of a computer, you've got your environment, you've got the tools, and if you haven't got the tools, I'll even talk you through getting the tools so you can set it all up. You don't really have anything to worry about. The book is pretty much enclosed. Everything you need is within the actual book itself. And if you need to go anywhere, just gives you the instructions, and you shouldn't have much of a problem.
Excellent. That's really useful, because I've been, like I say, I've read technical books before where it's like, okay, go find a repo of your own and make some changes, and I'm like, well, that kind of, whilst I agree that there's nothing better than practical experience, I'd prefer to be sort of walked through a few things,
Yeah.
So what was the impetus? What was the drive to write this book then, if you don't mind me asking?
It's a good question, actually. It's funny how it came about. I was approached, first of all, by Packet Publishing. So I never actually approached them to write a book. They actually approached me. And I had ideas about, I'm writing a book. I'd probably like to write a book about something I'm into, like reporting, that kind of thing. But they says, actually, we've got a book in mind. It's a book on clean code. And I thought, well, that's interesting. I thought, in all the places I've worked, that one of them has really done clean code. We don't use like practices like TDD, BDD or anything like that. And it's just like, just get the code done, right, get it out the door. It doesn't matter if it's got bugs, we can fix them later on, that sort of thing. Or you can leave refactor until later, but then the refactoring never happens, so the product just gets worse and worse and worse and worse. But when I was in such places, and we had like issues where like code is slowed down, I was called upon to like make it run faster, whether it be SQL code or VB6 code. And in some cases, I was getting like 8,000% increase because of the way I was writing, cleaning the code up, getting rid of dead code, and all that. So I thought, I've got a bit of experience in this, but I thought it would really be nice to actually, because obviously you pick up bad habits as a programmer when you're working in certain teams, because you've got to like mold yourself into that team. And then basically, because you're programming with them on a day in, day out basis, obviously you develop the team's habits. So I thought, well, it'd be good to actually write a book on clean code, because apart from applying what I already know, and that I've picked up, I can actually really study the topic in depth myself and put as much goodness in this book, one for myself as a programmer so that I develop my own skills, but as I'm developing myself, also develop the reader along with me. So it's like a journey we both take together, essentially. And so that's what prompted me to say yes to Packet Publishing.
I like that. One of the reasons that I got initially into blogging stuff and then pivoted into podcasting is just quite literally to force me to learn more. Because I was finding that, I was sitting around doing nothing. That's probably not the right word. But, I felt like I was spinning my wheels and not learning much. And then I decided, you know what? I'm going to write a blog post on this thing. So that means I've got to go learn it. And just learning and turning that information around and teaching someone else is, I've got a background in teaching, right? It's one of the best ways to learn, or rather to reinforce that learning.
Yeah, because I actually received that advice when I was looking at a website, and it did say that if you really want to learn something, teach somebody. And I thought, well, yeah, that's a really good way to do it. And so for me to learn clean code, the best way for me to learn it is to teach. And the best way to teach in this regard is to actually write a book on the subject, and that's why this book exists.
Excellent. I have to say that's a brilliant reason for writing a book. Like I say, it's my own experience as a teacher. We used to always get the kids to echo back to us what they'd learned, but in their own words, which is essentially, it's reducing what you're saying, but it's essentially what you're saying. I'm taking my experience and putting it out there for people to read, and it will help me to remember it too. I like that.
Yeah.
So then, okay, so the book is called Clean Code in C#, and it's about refactoring code. So I guess the important question to start with is, what is clean code, right? Because I feel like clean code to one person may not be clean code to another person. And I found that when I'm trying to talk to juniors or mentoring people who are maybe not in the business, and I'm talking about clean code, I have to use really amorphous phrases like code smell, right? Because these feel like they're things that you don't really, there is no real description of them until you've got experience. So I'm wondering, what is clean code, and is it all about hard and fixed rules, or is it more sort of malleable?
It's malleable. First and foremost, I think the best thing to do is to, first of all, say about a project I worked on. It was a marketing application, and it was really bad spaghetti code. And you couldn't really extend it, and you had to work around things. And if you was to change and refactor the code, it was that badly entangled that you would actually introduce bugs in a lot of different areas. And so it was, prior to me, they tried to redesign and rewrite the application 3 times, but they failed. They got me in on it, and even I failed. And I said, look, at the end of the day, the only way you're going to actually do anything with this application is to just have it as a maintenance release. So that basically you just keep it going in its current form. You rewrite an application from scratch that's properly spec'd, that meets your requirements, but you write it in a clean way that's object oriented. And in that way, you'll be able to put extension points in where you can easily grow the software. But also, if you make sure that the code is, it has comments where it needs them, but other than that, the code itself is you can read it like a book. You can just follow through the code and you know exactly what each piece of code does. You'll have a better success doing it that way. So I think in some ways, clean code is maintaining existing bad code where you keep it going. You don't introduce new bugs, but when you're actually having to maybe just add a few things here and there, it only does what it needs to do, no more, no less. When you look at the names of things, they're not cryptic, so you know exactly what they are. So if something's a people counter, you know it's a people counter. If something's encryption, you know it's encryption. If it's decryption, you know it's decryption, etc., 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 etc. In other words, you don't have to second guess what's meant by the name of a method, or the variable, or the class, or the namespace. Another aspect of clean code, I think, is properly packaging, the use of, making proper use of namespaces, grouping things together, and also is keeping your class minimal so that it only contains what it needs to. It doesn't do more than it needs to, and it does exactly what the name suggests. So if you've got for instance, you've got file system helper class. In that class, you would only expect to see things to do with file help, like the file system, like checking if a file exists, reading files, writing to files, etc., etc. You wouldn't have anything outside of that within the file. And then also with your methods, trying to keep your methods as small as possible, so that they don't have reams and reams of code. And your methods, when they're doing like things like iteration, you try and keep iteration as small as possible, and you don't have like levels and levels and levels and levels of iteration where basically you can get lost. And maybe thinking about, if you've got like a massive switch statement, is it possible that you can actually program that piece of code in a different way, maybe using like some other like kind of design pattern, whereby you're not having to like go through a big massive case statement, because yes, they do work, yes, they're easy to manage and all the rest of it, but is it really the best way forward? And so really, with a method, if you can try and keep methods below 10 lines if possible, it makes it readable. It makes it more manageable. I mean, I've worked on single methods, which I've inherited, which have just been lines and lines and lines of code. And the amount of nesting in them has made them really unreadable and unwieldy. And on top of that, you've had like cryptic names, and it just adds to developer stress. So I think part of clean code as well is making it so that you reduce the complexity of the code, like you try and reduce the number of pathways through the code. You keep the code as simple as possible. It is human readable, where even if the words are human readable, it's not quite clear what's going on. You just add comments and things like that. To me, that is what clean code is all about.
That all makes sense. The two things that I usually say is I quote a TV show, and I quote Steve McConnell from Code Complete 2. One of the things that he says is the most important thing for code that you write is that it has to be understandable by human beings. I believe he uses the word prime directive, so he's riffing on Star Trek. But, the code that you write, the code that I write, the code that someone else writes has to be readable by someone else. And that someone else could be you tomorrow, right? Because tomorrow you're not going to be the same person that you are today. You'll have the same experience, but you may not have the same sort of short-term working knowledge contents, right? And I think I completely agree with you about classes having, the bare minimum of what they need to do. And the way that I explain that is I riff on a TV show called MASH. There's a character called Charles Emerson Winchester III, and he says, "Gentlemen, I do one thing at a time. I do it very well, and then I move on." Now, obviously, he's being really facetious and horrible, but I like to apply that to classes and methods that I write, that the method will do one thing. That's all it does. The class has the bare minimum that it needs to do whatever it needs to do, right? And I think those sort of fit well with what you've said.
Yes.
And I think the point about writing code for other people to read is a bit of a disarmer. I think it disarms people who want to, look at how clever I am. I've written a multi-stage ternary or something, and you're reading it and you're going, I'm actually getting a headache from reading this. Yes, the compiler will probably turn it into that, but you're not writing code for the compiler, right? You're writing code for other people.
Yeah, and in my work time, I've experienced that in one place. There was a guy who, to be fair, he was really, really clever, far cleverer than what I was. But people did actually complain that even though his code was clever, he needed to actually add the comments just so that we knew what the code was actually doing. And so, if performance is an issue and you need to write such code, but to a normal everyday human who's maybe not as advanced as what you are in your skills, and they're not really going to understand what's going on, then I think the best thing to do is to most definitely make it human understandable to the normal lay programmer, by just simply stating what it's doing and why.
Absolutely, and I think you've hit on, from my point of view, a really, really important point about comments. And I'm sure you cover it in the book, and I'm sure I've read it 100 million times elsewhere. And I'm not trying to say that this is something that's not unique to you, but what I mean is when somebody writes, I don't know, var I equals 0, and then they put a comment, sets I to 0, and I'm like, that's useful, but you're not telling me why you did it, right?
Yeah.
And I think that's the important thing, is to explain why you're doing what you're doing and what it's actually doing, like the idea behind what it's doing, rather than, I could write a method that parses some obscure data format, right? But someone else reading that code will likely not understand what the data format looks like just by reading my parsing code, right?
That's right. And the other thing you've got to be careful of as well is, and I've experienced this in the workplace, where when there's like an excessive amount of comments and unnecessary comments, you can get developers where they get really upset, but they can actually get very angry and even explode within the workplace. And so comments can actually be an actual source of like real severe stress on fellow programmers. And so that's why it's important to get the balance between having no comments with code that's readable and having comments where they're actually needed.
Yeah, absolutely. And there is something that you mention a number of times in the book about developer stress, coder stress, code reader stress. And I absolutely love that, because you talk in the book about if you do it this way, it will reduce the chances of someone who's reading your code becoming stressed. And I feel like that isn't something that's touched upon in many other books about, solid principles, clean code, and all that kind of stuff. It's not mentioned, but I feel like it should be, right? Because if you're reading some code and you don't know what it does and you don't understand it and it's not well written and it isn't documented and there's no comments and there are, var A, var B, and you literally don't know what it's doing, you're going to get stressed, right?
I mean, with I'm working on one now, and it's massive. The project, there's loads of like different libraries all over the place. You've got stuff in like C#, you've got stuff in Java, you've got like different reporting mechanisms, and the actual company has quite a high turnaround. And I believe that part of the reason why it's got a high turnaround is because there's hardly any documentation. The code is so disparate. There's people have like permission to see certain parts but not other parts. There's like a lack of like team communication and focus, but the thing is there's no real documentation, and with a high turnaround you have a lot of brains coming, gaining knowledge and then leaving with that knowledge, but then when they leave, that knowledge has gone with them but it's no longer in the company. And like, it can be so stressful trying to actually reach your targets and your deadlines when you're being blocked because of lack of information, and because nobody knows what the correct way to actually do something actually is. And that's why when you're writing clean code, documentation is a really important part of that. And so the documentation is like twofold really. First and foremost is having your good specifications, which are not ambiguous and which do not lack information. And secondly, it's making sure that whoever's responsible for the architecting of the actual system properly document it, whether it's themselves or a combination of themselves and the people working on the system who actually produce the actual various sections of the actual code. It pays to actually have it properly spec'd and properly documented from a high level document overview, like with diagrams, for instance. If you've got loads of moving parts, how all these parts fit together, how they link to the database, etc., etc. And then when it comes down to the code level, that is then when you would have like your API documentation, like through the use of REML, all that kind of stuff, and like Swagger. So it's important to do these kinds of things, and they do actually reduce stress. Whereas if you don't do them, and people don't know what one part of the system does, or okay, I need to fix this bug, but whereabouts do I go? And they're trying to follow it through, and it's so heavily into dependency injection that you've got so many moving parts. But because you're using dependency injection, there's no overarching architectural diagrams, and it's not clear what's being injected and where what is being injected is coming from. Again, it's like so unbelievably stressful, and you can eliminate a lot of that stress if you have got a really well-architected system that's well-spec'd and well-documented.
I agree completely, because there's something that I always say, and that's the customer. And customer can be an internal customer, it can be an external customer, it can be, Bob down the street, it could be the project manager, it could be anyone, right? The person that you are writing code for doesn't know what they want until you give them what they don't want, right? And that's something that I've fallen into the trap of many times over my career, because, like you say, human language is so ambiguous, right? You end up building something, and then you build on that thing with assumptions, and then you build more assumptions, and then you end up completely in the wrong place. And I think it's so important to have the documentation and to have specifications to hand and to build the software. Perhaps, some people don't like to do TDD and BDD, but if you are doing TDD and BDD, to build those things from the spec and then build the software from that, like you say, because then you have the confidence that what you've delivered is what was requested, right?
Precisely. That's one of the reasons as well why I think the Scrum software methodology is quite good in doing things in 2-week sprints, especially on like greenfield projects, because right from the start you might have like the specification from the customer that's been signed off, and the customer might be thinking, yeah, this is what I want, so deliver me it. Now the thing is, if you're only developing in 2-week time frames, when it comes to actually releasing that 2 weeks worth of work to like a test environment for the customer to look at, when you demonstrate what you've done, they can then say, well, nice one, yeah, that's good, or you haven't quite understood what we've been asking, so you really need to change that. Or it could be, well, I know that's what we asked for, but thinking about it now, really, we don't actually want that. What we really need is this. And so I think that's why properly implementing Scrum, but where you are actually doing an actual release at the end of that 2 weeks to the customer, not necessarily into the production environment, but into some environment where you can actually demonstrate it to the customer. That can also work towards a clean system, because rather than say like develop 6 months worth of work, it goes and gets released, and then you find out that there's a major architectural flaw because the customer has finally realised that they need something doing in a certain way, but the architecture now no longer is able to actually cope with making it a simple change through expansion. You've got to do like a major architectural change. By starting off on the right foot, using something like the Scrum methodology, where you actually do an actual physical release every 2 weeks and demonstrate it to the customer, you can be saving yourself and the customer major headaches further down the line.
Absolutely. I think this will age me, but I'm from the very, very, very tail end of Waterfall and the beginning of Agile and Scrum. So at the very, very beginning of my journey into development, there was lots of, Waterfall was slowly becoming out of sync with the rest of the world, because in Waterfall methodology, you literally work on a project for 1 to 2 years, maybe even 3 or 4, and then deliver it to the customer. And that's when you find out, like you said, that it doesn't fall in line with what they want. And that's why I'm always a big proponent of, regardless of whether you do Agile, Scrum, or some other way, have these sort of frequent deliveries, maybe 2 weeks, maybe a month, maybe a week, whatever it is that fits with the rest of the team and how you can deliver those deliverables. And I'm very much a case of always have code in a position. Everything that's checked in, at the very least, in source control, is in a state where it can be delivered if needed. So you've not got like a feature that's half built or whatever that's already in source control in your main trunk or whatever, your main branch that Live is built off of. Live should always be buildable and deliverable, I guess. And I guess the only way that you do that is by doing very short iterations.
Yes. I mean, we do that here. We have like 2-week sprints, and they work really, really well. We do hit blocks, sometimes where it goes over sprints, but the majority of the time we do actually meet. And then at the end of the month, we'll have a monthly get-together. And then that's when we demonstrate it to the senior management. And then that helps them to see how progress is going on behalf of the development team. And it works really, really well. We don't necessarily release that to the customer, as in the external customers, but internally, because we are the ones who provide the schools with what they want. The senior management will actually have schools that they will release slight bits to, just to see how it goes. And it does actually show when there is actually problems. I mean, just recently we had to scrap a certain project. Well, not so much scrap it, but put it on hold for the time being, because in the time frame it was required, there was no way we could have delivered, because what the customer wanted would require like a really big architectural change. So it wasn't really practical. So if you was designing systems from scratch, that's why it really pays to sit down, have a blank canvas, think about what you really want, document it, iron out any ambiguity with specifications, and then when it comes to actually developing any project, it's probably prudent to go down the TDD/BDD software development paradigm, because that way, if you do that and you only do 2-week sprints, and every single sprint you are actually, through discipline, releasing to the customer, and you're only checking in code 1 that works and that 2 is feature complete, then you're going to end up with a more robust system, a system that the actual customer actually wants, but also you're going to end up with a system that your developers actually end up enjoying working on. Because at first, when it comes to doing anything like TDD or BDD, you do meet with a heck of a lot of resistance. Part of that resistance as well is, oh yeah, but TDD is time consuming. Oh yeah, but it requires loads more code. But sometimes when you actually write the proper code, as in like you test that fail and then only the amount of code you need to actually make it work and then refactor it, you can actually end up with less code than if you do just jump into it and start developing. Because, for instance, writing all that code that the customer doesn't want means you've wasted all that effort by writing all that code when you could have written less code and given the customer what they want.
Oh, absolutely. And it also means that you're creating, I guess, a maintenance requirement on the code that you've written that wasn't needed, right?
Yeah. So with code as well, if you ever have to common blocks out to try something, if it works, what you're trying out, and you no longer need that commented out block, like where we work now, that's got to be removed. You cannot check that into version control. And that's good, because if you look at it, it keeps your source file smaller. You've got less to read. You don't have to go through loads of scrolling if you're commenting out loads of code. So again, that adds to making it more readable, more maintainable as well.
Absolutely. And when I've seen commented out code in the code base, I've said, hey, you realize your source control provider can give you that code back if you need it in the future, right?
Yeah.
Yeah. So I guess one thing I'd like to ask, if that's okay, is let's say I've got a block of code, maybe a class, maybe just a method, and I want to refactor it, right? I'm looking at it and I'm thinking, this doesn't look very clean to me. I think there's a code smell there. I think there's perhaps something we didn't touch on, but an anti-pattern there, and maybe I can make this better. Maybe I can make it more testable. Do you have any prescribed steps of how to tackle that? Because I can imagine that if I'm looking at a method and thinking I need to refactor this, that could be a monumental task if I don't know what the common steps are. So let's say you've got a method in front of you and you need to refactor it. What are your common steps?
Well, first of all, I look at the size of it, and I look at the naming that's being employed. Does the names actually correspond to the coding standards what the company has? Because sometimes it's surprising how many times, especially if you get new developers coming, that the naming and the way the naming has been carried out is not in keeping with the coding conventions. And so, obviously, you would make sure that that code is renamed to use the coding standards within the company. A good way to automate that would be to use linting, so that every time your code builds, if any of the coding standards are actually not met, that constitutes an error in the code and it will not build and not run, and so you will have to fix it. And so that's a way to actually negate having to go through and fix somebody's code where they haven't actually used the correct naming standards, or where yourself may have even let it slip, which is quite easy to do if you're under pressure. So, first of all, it would be when refactoring code, the first thing I would do is just try and actually put in place some kind of linting tool, and make sure that the coding guidelines are agreed by the actual team. And when the team agrees, then obviously the linting gets put in place. Then is to actually look at the class, what you're working with. Can that class actually be split out into more specific classes? If so, do that. And then give it a run through, just make sure you don't break anything. Then, once you've split your classes out and you're happy that your class only has in it what it needs to do, can the methods be made smaller? Can you farm out, if it's a big method, can you break it down into smaller methods and give them methods meaningful names for what the task is they're actually performing? Also, does the class have the method have a lot of parameters? If so, does that mean that the method is actually doing more than it needs to? Is there a way to actually reduce the number of parameters that that method actually needs? Again, maybe even like writing a property class or whatever. Things like that. And do you have anything like magic numbers? If so, how about replacing magic numbers with enumerations? Do you have multiple classes that are actually doing the same thing, but maybe a bit differently? Would it pay to actually have them actually implement an interface? Would it be pay to actually have a base class that actually has the base functionality that implements so much of what you want as well? So that more and more you find that you write in smaller classes with less functionality in them. Is there any patterns? Is there anything where you're doing something of a repetitive nature, but you may be doing the same thing differently in different areas? Could you actually use a design pattern for that? And if so, then do so. And just things like that. And one of the best things I can recommend when it comes to refactoring is have a look at tools like Resharper. Resharper is an excellent tool for helping you identify dead code, code that's not really performing at its best, identifying areas which are bottlenecks, and all that kind of thing. It identifies a whole load of different code smells and helps you to refactor them, and it's a really, really good tool. Another thing is if you see some code there and you're thinking, I don't know if that's the best way to actually do something and performance is really an issue, then you could maybe look at using something like benchmark.net. And like with benchmark.net, for instance, you can write 2 different methods, or maybe 5 or more different methods that all do the same thing. And you can benchmark them, and then out of all of them, you can actually pick the best method from that, so that when you're refactoring your code, you know that your code's going to be fast and does exactly what you need it to. If you're using test-driven development and you're wanting to refactor a piece of code, if it doesn't actually have any tests in place, you could actually add them to actually test it. Obviously, you'll need your perfect path through the code. You'll need your invalid data values, and you'll need like your null value to be passed in, etc. to see how it handles all those different aspects. If your team is against test-driven development and they're against using things like BDD, then really you're probably just going to have to use your best judgment on like refactoring, making sure the code does what it does. But I think the key, however you do it, is to make it so that it's isolated, in that it's as loosely coupled as possible. It's enclosed and encapsulated, and it only does what it needs to do. And if it's doing, even if it is only doing what it needs to do, if you can farm the internals out to other methods so that you reduce the readability of the size of the methods, but the methods have the meaningful names of what that parent method is actually doing, that can also be really, really good. And so yeah, there's some of my tips.
Excellent. Those are some really, really good tips, I have to say. When I started my career, and somebody said to me, right, refactor this to make it smaller and cleaner and more efficient. And I was like, I mean, just rewrite it. That's how do I know what it's actually doing? But yeah, to have someone actually say, these are some tips, these are some places to start. That I feel that's quite useful. And there's everything that you've said there makes a whole bunch of sense as to where to start and how to go forward. So I think that's a wonderful answer to that. And of course, there's also buy the book.
Yeah, there was that as well.
So talking about the book, would you mind reminding the listeners the name of the book and maybe where they can get it from? I know that it's available from Pact or Packet or however they pronounce their names, right? But I know it's also on Amazon and stuff like that. So is that would you mind just sort of reminding people the name of the book and things like that?
Yeah, so the book is Clean Code in C#. It's by Packet Publishing and by myself, Jason Halls. You can buy it on, I think it's Barnes Noble, Amazon, Packet, and I think it's also available on other booksellers as well. And I think it's also available on Kindle books.
Oh, right, okay. So it's I would say that's practically everywhere. I mean, if we don't know about it, may be available on the Apple Store as well. We don't know. Have a look. Let us know if it is. Let us know if it's not. I'm okay with you reaching out and letting us know. But I also I've heard through a birdie that you're working on another book. Is this a super secret project, or is this something that you can talk a little bit about and maybe whet the listeners' appetites and get in clamoring for that second book?
Yeah, it's high performance code in C#, and basically it's taking different ways of doing code, benchmarking them, and letting you see that they're doing the same thing, but where you can actually see from the benchmark report the performance. So you see how many milliseconds or nanoseconds it takes to run a piece of code. You can also see like memory allocation, etc. And so when you're writing code where performance is essential, but there's many different ways of writing that code, I talk you through step by step writing the actual code to actually show different ways of doing something, and using benchmark to actually produce a report to show you exactly which method out of all those ways is the best way of doing things. I also use things like .trace, .memory, and things just so that you can actually see like memory allocation and the way a piece of code affects like your network traffic and all that kind of thing. And so it's just really helping you to understand different tools and ways of identifying the best possible code that you can write for your particular situation to make it that your code runs at its best. And that's basically what the book is about.
I like it. There's not many books I think out there about high performance .NET, and I think it's something that I guess doesn't really get talked about, at least in my experience, where the places where I've worked, the customers I've worked for, where, the tests have been, does it do this thing? Can we do an end-to-end thing? Can I call this API and watch it go all the way through? Can I check the database? But they've never really been on sort of throughput, which I guess is where performance comes in, right? Because if you've written some wonderful .NET code, and maybe it's in a function, maybe it's in a microservice, maybe it's in a monolith, because let's play buzzword bingo, and suddenly a million or a babillion or a quintillion or whatever the numbers are, users hit that piece of code. You need to make sure that it's not going to blow up the server, right?
Yeah. And so that's why, like your performance monitoring and your health monitoring is like really important. So using things like analytics can help you actually see exactly what people are using to access your system, how many, what times are actually peaking, and that allows you then to actually allocate more resources. But from a programmer perspective, there's lots we can be doing, because we can actually be there benchmarking our code. We can be checking load balancing, have a testing phase. So we can load balance. We can write code that's been benchmarked to make sure that it's the most performant code. And we can pass that then to our testers, who can then make sure that through the load balancing they can actually mimic, say for instance like it's schools in the UK. We know that schools in the UK are going to be using the system from anywhere from like 8 o'clock all the way up to we'll say like 5 o'clock. And the peak times are probably going to be between 9 and 3, with a lull between like the different break times. And so what we can actually do is we can model our systems and do load and stress testing around that kind of capacity. So let's say if we know roughly like maybe how many schools we've got, how many students we're going to be having, and we can put our software through that stress testing to see where it's going to fall over. But within the application itself, it can also have health monitoring and exception logging, so that we can actually identify if there's problems, and if there is problems, whereabouts they actually are. And for instance, you maybe have like an error 500, server busy, etc. Well, we know that means it's too many people are actually accessing the system at that moment in time. And so obviously that code cannot handle that number of people at any one time. So it's like, right, is there anything we can do with this code that we can actually do to improve performance, other than just get more hardware, more load balancing in place? Is there actually anything we can actually do with the actual code? Well, first of all, it's hitting the database hard. Okay then, right, on the database side, can you actually improve the queries that it's actually generating? Can you add things like indexes? Can you actually change the ordering of the query so that it's still bringing back the correct information, but the filtering is actually reducing the number of records that are going to be processed, so that the query executes faster and is returned faster? Is there any particular code that's actually a bottleneck that could be found out elsewhere, so that it's not under so much stress? Are you using the best query method? For instance, if you benchmark IEnumerable versus IQueryable, it's IEnumerator versus IEnumerable. IEnumerator is a lot faster than using IEnumerable, for instance, when you're going through loops. Once you've actually got your data and you're actually processing it on the actual C# side. So there's loads of things we can actually be doing to make sure that when our code goes out, it doesn't blow up in the customer's face.
Excellent. Well, I'm going to look forward to seeing that getting its release, because that's something that I'm always looking to do. I'm always looking to make, to tweak my code to get as much processing throughput for a CPU cycle as possible, and I'm terrible at it. So I'm definitely looking forward to that, Jason.
Thank you.
So, as one last question then, how can the listeners get in touch with you or learn more about you? I mean, you don't have to let them get in touch with you, that's fine. But, how can the listeners learn more about you and some of the projects you're working on, or find out more about when this second book will be released? Because obviously it's going to be done when it's done, right?
Yeah, it will be done when it's done. I mean, it's quite technical, and I'm hitting a few problems, especially since some of the code is still in preview. So obviously things change as you're writing. You've got to read your code, etc. But they can reach me on LinkedIn. I'm on LinkedIn. I also have a blog, jasonalls.wordpress.com. I post articles on there. So, I mean, every so often if I come across technical issues that I hit, I'll put them on my blog. And that's just a reminder for myself, but also it does actually help a fair few people from around the world. But if they actually ever want to ever contact me, you can just get in touch on LinkedIn.
Excellent stuff. Excellent. We'll have links to all of those things. Everything we've discussed in the episode, there'll be links to all of that in the show notes. So, do click through and check those out. There's always a section, links or interesting links towards the bottom of the page. So do check those out. And I guess all that really remains to say is thank you ever so much, Jason.
And thank you.
I really appreciated. You're very welcome. I really appreciated you taking the time to talk to me today, and I'm sure the listeners will too, because, clean code is one of those subjects that I feel like everyone should be aiming for. You don't have to hit it every time, but, you should be aiming for it, because it helps to increase your code quality. And as a software craftsman, or craftsperson rather, I'm always looking for, how do I make this better? How do I make this easier to read? How do I make this easier for the CPU to run through? What's the best way to improve this? So thank you ever so much, Jason.
You're welcome.
That was my interview with Jason Olds about clean code and his book Clean Code in C#. Be sure to check out the show notes for a bunch of links to some of the stuff that we covered and a full transcription of the interview. The show notes, as always, can be found at .netcore.show, and there will be a link directly to them in your podcatcher. And don't forget to spread the word. Leave a rating or review on your podcatcher of choice. Head on over to .netcore.show/subscribe for ways to do that, or reach out via our contact page. And as always, remember to come back next time for more .NET goodness. I'll see you again real soon. See you later, folks. The .NET Core podcast is a production of RJJ Software Limited.